Fakultas Kedokteran Universitas Sumatera Utara merupakan fakultas kedokteran tertua keempat di Indonesia. Fakultas ini berdiri pada tanggal 20 Agustus 1952. Diawali dengan 12 orang dosen dan 26 orang mahasiswa. Pada tanggal 20 November 1957, USU diresmikan oleh Presiden pertama Indonesia, yaitu Insinyur Soekarno, sebagai Universitas Negeri ke-7 di Indonesia. Letaknya yang berada di sisi utara Pulau Sumatera membuat FKUSU menjadi pintu gerbang akademik dengan semangat perubahan untuk meningkatkan sarana pendidikan dan menciptakan lulusan terbaik agar bisa berbakti kepada negeri. Untuk menciptakan lulusan terbaiknya, Fakultas Kedokteran USU mengelola 26 program studi yang didukung oleh 308 dosen tetap yang jumlahnya terus bertambah. Di antaranya merupakan 21 guru besar, 111 bergelar doktor, dan 169 mempunyai pendidikan konsultan. Tidak hanya itu, fasilitas-fasilitas yang memadai pun dibangun untuk mendukung berjalannya proses pembelajaran di Fakultas Kedokteran USU. Beberapa di antaranya adalah saat ini, terhitung jumlah mahasiswa FKUSU berjumlah 3.500 mahasiswa. Setiap tahun FKUSU meluluskan kurang lebih 700 mahasiswa dan lebih dari 16.189 jumlah alumni FKUSU telah tersebar di seluruh dunia. Fakultas Kedokteran USU dipimpin oleh Profesor Dr. Aldi Syafruddin Rambe, spesialis saraf konsultan, sebagai dekan dan 3 orang wakil dekan. Fakultas Kedokteran USU memiliki visi
menjadi institusi penyelenggara pendidikan kedokteran yang bermutu, serta menuju Center of Excellence di bidang kedokteran tropis dan onkologi pencegahan di Asia Tenggara.
Demi terwujudnya visi kami, berbagai kegiatan dan program pun kami lakukan untuk sebuah pencapaian. Profesi dokter merupakan profesi yang sangat mulia dan penting bagi keberlangsungan hidup manusia. Oleh karena itu, FKUSU menekankan pentingnya nilai-nilai keluhuran individu yang erat dengan integritas dan moral untuk memberikan dampak yang besar bagi kesehatan masyarakat dan perkembangan dunia medis. Melalui komitmen, inovasi, dan kerja keras, FKUSU mendapat akreditasi unggul berskala nasional. Sejumlah penghargaan pun diraih oleh para dosen dan juga mahasiswa Fakultas Kedokteran USU. Karena kami yakin, untuk mencapai kesuksesan membutuhkan kerja keras dan juga kerja cerdas. Dalam usaha untuk menjadikan Fakultas Kedokteran USU sebagai institusi pendidikan kedokteran terdepan menuju Center of Excellence, dibutuhkan inovasi dan kerjasama dengan seluruh elemen masyarakat dan pihak terkait. Melalui rencana tersebut, FKUSU merancang berbagai pengembangan, diantaranya laboratorium terpadu. Dengan harapannya FKUSU bisa menjadi institusi penyelenggara pendidikan kedokteran terbaik dalam sejarah pendidikan Indonesia menuju Center of Excellence di Asia Tenggara. Fakultas Kedokteran USU bertekad untuk terus berinovasi dan berkomitmen dalam menghasilkan lulusan yang berkualitas dan membangun sarana pendidikan yang terbaik, agar mampu memberikan kontribusi besar sebagai institusi penyelenggara pendidikan kedokteran terbaik dalam sejarah Indonesia. Fakultas Kedokteran Universitas Sumatera Utara merupakan fakultas kedokteran tertua keempat di Indonesia. Fakultas ini berdiri pada tanggal 20 Agustus 1952, diawali dengan 12 orang dosen dan 26 orang mahasiswa. Pada tanggal 20 November 1957, USU diresmikan oleh Presiden pertama Indonesia, yaitu Insinyur Soekarno, sebagai universitas negeri ke-7 di Indonesia. Letaknya yang berada di sisi utara Pulau Sumatera membuat FK-USU menjadi pintu gerbang akademik dengan semangat perubahan untuk meningkatkan sarana pendidikan dan menciptakan lulusan terbaik agar bisa berbakti kepada negeri. Untuk menciptakan lulusan terbaiknya, Fakultas Kedokteran USU mengelola 26 program studi yang didukung oleh 308 dosen tetap yang jumlahnya terus bertambah. Di antaranya merupakan 21 guru besar, 111 bergelar doktor, dan 169 mempunyai pendidikan konsultan. Tidak hanya itu, fasilitas-fasilitas yang memadai pun dibangun untuk mendukung berjalannya proses pembelajaran di Fakultas Kedokteran USU. Beberapa di antaranya adalah saat ini, terhitung jumlah mahasiswa FK-USU berjumlah 3.500 mahasiswa. Setiap tahun FK-USU meluluskan kurang lebih 700 mahasiswa dan lebih dari 16.189 jumlah alumni FK-USU telah tersebar di seluruh dunia. Fakultas Kedokteran USU dipimpin oleh Profesor Dr. Aldi Syafruddin Rambe, spesialis saraf konsultan, sebagai dekan dan 3 orang wakil dekan. Fakultas Kedokteran USU memiliki visi
menjadi institusi penyelenggara pendidikan kedokteran yang bermutu, serta menuju Center of Excellence di bidang kedokteran tropis dan onkologi pencegahan di Asia Tenggara.
Demi terwujudnya visi kami, berbagai kegiatan dan program pun kami lakukan untuk sebuah pencapaian. Profesi dokter merupakan profesi yang sangat mulia dan penting bagi keberlangsungan hidup manusia. Oleh karena itu, FK-USU menekankan pentingnya nilai-nilai keluhuran individu yang erat dengan integritas dan moral untuk memberikan dampak yang besar bagi kesehatan masyarakat dan perkembangan dunia medis. Melalui komitmen, inovasi, dan kerja keras, FK-USU mendapat akreditasi unggul berskala nasional. Sejumlah penghargaan pun diraih oleh para dosen dan juga mahasiswa Fakultas Kedokteran USU. Karena kami yakin, untuk mencapai kesuksesan membutuhkan kerja keras dan juga kerja cerdas. Dalam usaha untuk menjadikan Fakultas Kedokteran USU sebagai institusi pendidikan kedokteran terdepan menuju Center of Excellence, dibutuhkan inovasi dan kerjasama dengan seluruh elemen masyarakat dan pihak terkait. Melalui rencana tersebut, FK-USU merancang berbagai pengembangan, diantaranya laboratorium terpadu. Dengan harapannya FK-USU bisa menjadi institusi penyelenggara pendidikan kedokteran terbaik dalam sejarah pendidikan Indonesia menuju Center of Excellence di Asia Tenggara. Fakultas Kedokteran USU bertekad untuk terus berinovasi dan berkomitmen dalam menghasilkan lulusan yang berkualitas dan membangun sarana pendidikan yang terbaik, agar mampu memberikan kontribusi besar sebagai institusi penyelenggara pendidikan kedokteran terbaik dalam sejarah Indonesia.
Take, seven, seven, two, left.
Bang? Nah itu Pak kamu.
Ya, bukannya di bawah sini aja. Mau pakai apa enggak ya?
Take, left, two. Take, left. Take, set, left, two. Take,
Pakai podium tak turunkan aja nih, pakai podium.
Pertama kali punya jerawat pasti panik ya.
Kok malah makin parah jerawatnya, sampai pakai inilah, pakai itu.
Mungkin orang mandang orang yang jerawatan itu jorok.
Aku jadi pakai masker mulu karena aku malu.
Selama 1 bulan akan dilakukan uji klinis untuk melihat manfaat dari penggunaan serum pada kulit yang berjerawat. Lalu hasilnya akan dievaluasi dengan berbagai instrumen.
Karena ngilangin bekas jerawat juga, selang 3 hari bekas jerawat udah mendingan.
Aku bersyukur banget jerawat aku juga udah mendingan daripada sebelumnya.
Saya sudah melihat sendiri bagaimana kulit yang berjerawat jadi lebih baik.
Salicylic acid, niacinamide, dan vitamin C terbukti efisien dalam melawan jerawat dan mencerahkan nodanya.
Seneng banget, bener-bener kayak bersyukur.
Gue percaya diri nih gitu.
Fakultas Kedokteran Universitas Sumatera Utara merupakan fakultas kedokteran tertua keempat di Indonesia. Fakultas ini berdiri pada tanggal 20 Agustus 1952. Diawali dengan 12 orang dosen dan 26 orang mahasiswa. Pada tanggal 20 November 1957, USU diresmikan oleh Presiden pertama Indonesia, yaitu Insinyur Soekarno, sebagai Universitas Negeri ke-7 di Indonesia. Letaknya yang berada di sisi utara Pulau Sumatera membuat FK-USU menjadi pintu gerbang akademik dengan semangat perubahan untuk meningkatkan sarana pendidikan dan menciptakan lulusan terbaik agar bisa berbakti kepada negeri. Untuk menciptakan lulusan terbaiknya, Fakultas Kedokteran USU mengelola 26 program studi yang didukung oleh 308 dosen tetap yang jumlahnya terus bertambah. Di antaranya merupakan 21 guru besar, 111 bergelar doktor, dan 169 mempunyai pendidikan konsultan. Tidak hanya itu, fasilitas-fasilitas yang memadai pun dibangun untuk mendukung berjalannya proses pembelajaran di Fakultas Kedokteran USU. Beberapa di antaranya adalah saat ini, terhitung jumlah mahasiswa FK-USU berjumlah 3.500 mahasiswa. Setiap tahun FK-USU meluluskan kurang lebih 700 mahasiswa dan lebih dari 16.189 jumlah alumni FK-USU telah tersebar di seluruh dunia. Fakultas Kedokteran USU dipimpin oleh Profesor Dr. Aldi Syafruddin Rambe, spesialis saraf konsultan, sebagai dekan dan 3 orang wakil dekan. Fakultas Kedokteran USU memiliki visi
menjadi institusi penyelenggara pendidikan kedokteran yang bermutu, serta menuju Center of Excellence di bidang kedokteran tropis dan onkologi pencegahan di Asia Tenggara.
Demi terwujudnya visi kami, berbagai kegiatan dan program pun kami lakukan untuk sebuah pencapaian. Profesi dokter merupakan profesi yang sangat mulia dan penting bagi keberlangsungan hidup manusia. Oleh karena itu, FK-USU menekankan pentingnya nilai-nilai keluhuran individu yang erat dengan integritas dan moral untuk memberikan dampak yang besar bagi kesehatan masyarakat dan perkembangan dunia medis. Melalui komitmen, inovasi, dan kerja keras, FK-USU mendapat akreditasi unggul berskala nasional. Sejumlah penghargaan pun diraih oleh para dosen dan juga mahasiswa Fakultas Kedokteran USU. Karena kami yakin, untuk mencapai kesuksesan membutuhkan kerja keras dan juga kerja cerdas. Dalam usaha untuk menjadikan Fakultas Kedokteran USU sebagai institusi pendidikan kedokteran terdepan menuju Center of Excellence, dibutuhkan inovasi dan kerjasama dengan seluruh elemen masyarakat dan pihak terkait. Melalui rencana tersebut, FK-USU merancang berbagai pengembangan, diantaranya laboratorium terpadu. Dengan harapannya FK-USU bisa menjadi institusi penyelenggara pendidikan kedokteran terbaik dalam sejarah pendidikan Indonesia menuju Center of Excellence di Asia Tenggara. Fakultas Kedokteran USU bertekad untuk terus berinovasi dan berkomitmen dalam menghasilkan lulusan yang berkualitas dan membangun sarana pendidikan yang terbaik agar mampu memberikan kontribusi besar sebagai institusi penyelenggara pendidikan kedokteran terbaik dalam sejarah Indonesia.
Assalamualaikum. Good morning and welcome to FKUSU guest lecture in One Health, New Problems and New Solutions. Please give applause to today's event. First of all, I would like to say welcome and thank you for our honorable guest, Dr. Associate Professor Harun Mahat from the Knowledge, Technology and Innovation Group, Wageningen University, and Honorable the Vice Dean of Faculty of Medicine of University of Sumatera Utara, substituted by Dr. Inke, as the Vice Dean 3 of Faculty of Medicine University of Sumatera Utara. In this occasion, I would like to tell you that today's lecture is we invite from Wageningen University, Associate Professor Dr. Prof. Harun Mahat to send some information and something about the thing that maybe you will never heard in other places. Today's topic is about One Health, New Problem and New Solutions. More you will listen to Dr. Prof. Mahat. Pada acara pagi hari ini, kita akan mendengarkan kuliah umum dari Profesor Dr. Harun Mahat dari Wageningen University dengan topiknya adalah One Health, New Solutions and New Problem. Pada kesempatan hari ini kalian akan mendengarkan lebih banyak lagi tentang topik-topik baru yang mungkin sebelumnya tidak pernah atau jarang atau masih belum banyak diberitakan atau dijelaskan di dalam ruang kelas. Jadi kita harapkan kita semua mendapatkan hal-hal yang berinformasi dan hal-hal yang baru yang akan disampaikan oleh Dr. Harun Mahat. Masuklah kita ke acara berikutnya, yaitu kata sambutan dari yang mewakili Dekan FKUSU yang diwakili oleh Dr. Inke Nadia Nianti Lubis, spesialis anak PhD. Kepada Dr. Inke kami persilakan.
Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. Izin saya menyampaikan dalam bahasa Inggris karena tamu kita hari ini berasal dari Belanda. So, good morning everyone. Good morning ladies and gentlemen. I would like to extend my highest gratitude to our guest speaker today, Associate Professor Harun Mahat from Wageningen University, who has kindly accepted our invitation to share his knowledge today. And his expertise would add great significance to our discussion. I would like to also thank you for Dr. Ihwan and Dr. Suna for organizing this event. So in recent times, our understanding of health has expanded beyond traditional boundaries, emphasizing the inseparable links between the well-being of humans, animals, and the environment. Today's discussion will unravel the complexities inherent in this interconnectedness and, more importantly, illuminate novel pathways to its solutions. The problems we face in this era are diverse and complex. Emerging infectious diseases, antimicrobial resistance, climate change, and other global challenges underscore the urgency for a unified approach, such as One Health approach. As we confront this issue, it is imperative that we seek solutions that transcend disciplinary silos and foster collaboration among medical professionals, veterinarians, environmental scientists, policymakers, and the broader community. So I'm very happy that many of our students with different disciplines can join us this morning. So I hope that you all can learn from Professor Mahat this morning. So the phrase "new problems, new solution" encapsulates the spirit of our exploration today. In facing unprecedented challenges, we also encounter unprecedented opportunities for innovation and progress. Through collective knowledge and collaborative efforts, we can redefine the way we approach health and pave the way for a more resilient, sustainable future. So I hope throughout this seminar, we encourage active participation, thoughtful discussion, and the sharing of diverse perspectives. So everyone, if you have any questions, please raise your hand, be active. Don't be afraid to ask in Bahasa. We have our moderator, Dr. Ihwan, and Dr. Suna also to help you in translating. So thank you again for joining us, and may this seminar be a catalyst for inspiration, collaboration, and most importantly, positive change. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you for Jacob for your opening speech. Now we are going to the main event of today's event. Is the guest lecture from Dr. Harum Maat. Dr. Harum Maat is a professor in Knowledge, Technology and Innovation Group from Wageningen University. His field is in food science and also in One Health. And he has a PhD in History and Science. And now please welcome Professor Harum Maat. He will pass to you.
I'm a bit tall, so equipment has to be adjusted to my height. Thank you very much for inviting me. Thank you very much for coming to my presentation. I'm very honored and pleased to be here in this beautiful building, in this Faculty of Medicine. It's also a bit unfamiliar terrain for me. I'm coming from Wageningen University. Probably you've never heard of this university. Because you're all medical students, or mostly you're medical students, I assume. Wageningen University is an agricultural university by origin, and still is in many ways. And as an agricultural university, we do have a very clear interest in health issues. Of course, a lot of the health issues we deal with are related to livestock. But increasingly, there is emphasis, unfortunately, I'm almost inclined to say, to what is termed One Health issues. One Health issues is mostly known for zoonotic diseases, so diseases that, pathogens that can jump and move between animals and humans. But as I hope to explain in my lecture, there's quite a bit more in terms of One Health issues. Another known example is antimicrobial resistance, which is also an issue that plays out both in livestock and animals and in humans. So there again, there's quite a bit of overlap. What I would like to start with, however, is my opening picture. Because as from an agricultural background, I often challenge my students, what do you see here in this picture? And I would like to start with asking you the same question. So maybe for convenience, we can do a bit of a poll with raising hands. Who thinks this is forest? This is wild forest? Anyone? No? Who thinks this is a farm? A farm cultivated by people, by farmers? Who thinks this is a farm? No one? Okay. Is it something in between? So an abandoned farm maybe, something that is not longer used and now is overgrown by other plants. Who thinks this is this? Okay, at least one hand, yeah. So by now you're the majority. It is a farm. So this is very actively cultivated. I mean, maybe the picture is a bit unclear, but of course you can see the banana tree. But if you look well, you also see a wide variety of crops. You see rice, you see cassava, you can see maize, and you can see a number of vegetables, okra, for example, and all these things are in this field. Again, of course, the picture is not obviously clear, but the thing is, this is how humans interact with nature. So it is deliberately chosen this picture to show that what we consider a farm, or what we consider nature, or what we consider cultivated areas is not always that crystal clear, right? And that is exactly what One Health is about. There's always fuzzy areas in the divide between what is wild and what is domesticated, what is cultivated and what is abundant. And that is exactly where pathogens thrive. They like that, because they can move between many different things. But at the same time, this is also perhaps the solution, because what we see increasingly in agriculture is that diversity, so having many different crops in one field, or having various varieties of a crop in a field, reduces the pest. You can well imagine if you have a pest that likes a particular crop, and there's many of the same plants in the field, the pest can just eat and eat and eat, right? It's just like an open invitation, come and eat. Where in this case, yeah, the pest can eat one plant maybe, but if it moves to the next plant, it finds out that the plant has a natural protection against it. There are studies from China in rice. You see it as one single rice field, but they have planted about 7 or 8 different varieties. That the pest pressure is going to reduce enormously if you do that. Again, the same mechanism. If the pests move from one plant to the other, it suddenly can deal with resistance of the different plant. It isn't just the same plant that is responding the same. So biodiversity and diversity in agriculture might be part of the solution, sometimes can also be part of the problem. Can I have my next slide? So just as a brief background, I'm a social scientist. I've been working in the science and sociology and history of science and technology. So that's quite a broad study. I focus mostly on agriculture and food, and in the last 5 or 10 years, I would say, also increasingly on health issues and One Health issues. What I will do is briefly explain a bit what One Health is. If I ask who have heard of One Health, how many hands get up now? Who has heard the term One Health before? Oh, no one. Okay, so this is really a one-on-one. Basically, okay, there's some people, of course, yeah. What I will try to explain that One Health is an approach, it's a field, but it's also a practice. You can do something on One Health, and it's not yet a study program on One Health, but there are increasingly universities, and I understood also in this university, modules and programs on One Health. And that's a very good and positive development. So increasingly, One Health will be the sort of new discipline of the future, perhaps, right? Yes, so, and I will also specifically focus on what technologies, what new innovations can do for One Health and how they are employed in One Health. International organizations, medical people typically look at the World Health Organization, WHO. We in agriculture focus more on FAO, Food and Agriculture Organization, but they have very similar definitions of One Health. So it's an integrated approach, they say. So you have similar problems. We had COVID, that's probably the biggest outbreak of a zoonotic disease we had witnessed over, well, maybe since the Spanish flu in the 1910s. Because of this, unfortunately, it was a sort of wake-up call. We need to do more on the integration between the different fields where these kind of pathogens emerge, which is indeed wildlife, because there's the assumption that the COVID virus emerged from wild animals. But these were not entirely wild animals because they were traded by people, right? So there's an element of, is it domestication or is it wild? Again, like from the first picture of my presentation, these are not always very clear-cut divisions. And that's exactly what One Health tries to do. They try to approach it almost as a holistic entity. So we need to understand these disease issues from an integrated perspective. A bit of social science in the One Health perspective. A lot of these interactions and a lot of these challenges emerge from how we as human beings, as people, deal with the global economy. Again, COVID is the best known example where the focus on the origin of the virus was very much on the pangolin, which is an animal that comes from Africa, but is widely in demand in China for all sorts of reasons. But the basic point is there is global trade. And global trade not only makes these risks emerge in some point and then appear in quite another point in the planet, but it also makes that these diseases, once they become zoonotic and pandemic or endemic, they can spread very quickly, well, across the world, as we witnessed with COVID, right? The first cases in China were probably in December or even a bit earlier, and in March the next year, 2020, it was all over the world, right? And that's because we have trade, we have tourism, we have all sorts of other ways in which human beings, do something with the economy, either spending their money in tourism or doing business, etc. So this human exchange with the economy is a very important reason. I put antimicrobial resistance there too, because that's another good example of how global trade, the economy that we all are part of, the global economy, is a very important driving factor in these diseases. So you need to understand these trade routes, these patterns, right? It's a very nice example of fisheries. I know Indonesia has a lot of fish farms where they they produce fish like shrimps and other kind of fish that they cultivate in big ponds or open water ponds. And in order to export that fish, you need to have your health certificates that you didn't use antibiotics for these fish, that these fish don't have any diseases, etc. Because the world and the receiving countries are very scared that with the trade they will also import diseases, right, pathogens. So there are very strict regulations on fisheries to make sure that your fish that you export does not show any signs of pathogens, basically. So this kind of control system, again, is a good example of how the economy deals with these One Health challenges, or how these One Health challenges are connected to the economy. Next, please. Again, another way of understanding One Health issues, it's our human relationship with, well, basically the micro world that we live in. I didn't include a picture, but in one of my other courses I used a picture of a human body, abstract image of a human body, and the amount of species that are on the human body. It's enormous. In our intestines, on our skin, there's so many different kind of bacteria, there's so many different kind of other small microbes, basically, that we live with. And if we are normal and healthy, we still have these huge amount of microbes in our body and on our body. And apparently it doesn't harm us. In fact, we even need them to digest our food. We need these bacteria, right? So we live in a sort of positive symbiotic relationship with many of these people. But of course, if there is a pathogen that makes us sick, then the system can disturb, we fall ill and we need treatment. So again, it's a fine balance. It's a tricky balance often when you live in healthy symbiosis and when you get ill from that kind of interaction. And that is what this slide tries to say. One Health is also a better understanding of our relationship with the microbiology of the environment. So it's not just on our body, it's also around us, right? So that's why we need this kind of integrated perspective. And this is something that one of the founders of microbiology, Louis Pasteur, is French. Well, if you are in a francophone country like Cambodia, you always have the Pasteur Institute, which is a big research institute from France. And he was one of the French first scientists who defined these microbes and these bacteria, etc. So he basically says we have to find a way to deal with these microbes, whether we like it or not. And the map again shows some of the emerging and re-emerging vector-borne and infectious diseases. So it's quite a map, quite some. So I just want to focus a bit more on two examples that I've been involved in studying. One is Ebola, which is probably luckily not common all across the world, so it's very focused disease. There was a big outbreak in West Africa in 2014-16, but it sort of re-emerges, and I'll come to it. The reason why it re-emerges again has to do most likely with the fact that there's trade, a lot of trade going on in West Africa, or in Africa in general. And yeah, the disease is very specific, so it is a virus, hemorrhagic virus. So it usually the symptoms are divided into what they call a dry phase, when you have headaches and well, the left side of the picture basically, muscle pains, weaknesses. And then it turns into the most risky phase, which is the wet phase, when you start bleeding, vomiting, etc. It is treatable if you are early enough and you treat the patients, especially hydration is very important. The patient can survive, but unfortunately the survival rate is well, it's low, relatively speaking, about 30 or 40% at best. And yeah, so these are some of the basic things of Ebola, probably known for medical students. Next, please. This is an interesting table because it shows the pattern by which Ebola outbreaks happened in different parts of Africa. And as you can see, the most recent one was in Uganda. And Uganda is not known as the most underdeveloped part of Africa. It's a relatively well-thriving economy with a relatively good health system compared to other Ugandan countries. But the reason there was an outbreak in Uganda was because it was in the border zone with the Democratic Republic of Congo. And Congo, as you can see from DRC, in the abbreviation, or Zaire, it's the same. Sorry, DRC in the country list. Is there very prominently for two reasons. One, of course, is that apparently the virus is very common there, and in fact it's first discovered in the DRC. Ebola is a river in the area, so the virus is named after the river where it was first found. But another important factor is that the country is in a mess. So there's a lot of internal warfare and rebellion groups, etc. There's a lot of international struggle, especially in the eastern area, about the mining there. So your smartphones and all your electronic devices need a lot of rare metals that come from that area in particular. So there's a lot of international attention for this area because of the mining that's going on. And that in itself creates traffic. It creates people going there and people moving around. And that makes that the virus can move with those people. Of course, I mean, it's a medical story and you're probably familiar with it. You need certain kind of patients, asymptomatic cases, to make the virus travel. So most likely the main reason why the virus still is existent and pops up in different places in Africa is because asymptomatic cases, they transmit it to a different place. This is another table. You don't need to read all the details, but if you just have a quick look, you can see that the figures, the numbers are very different, right? So it's not very similar numbers. Some is high, some is low. These are the number of cases from different districts in a small, relatively small area, a province of Sierra Leone, one of the countries that was very hard hit in the 2014-16 outbreak. And what does that mean? Well, if you go to the next slide, it means that the outbreak was not even across. It means that the outbreak was not evenly distributed across the country, and that is a major challenge because basically, if you have an epidemic, epidemiologists start to make a model, right? You probably had that in some of your courses. You can, based on the infection rate and the nature of the disease, you can build a model of how the disease will spread over your population, right? That's what epidemiologists do. And that's also what epidemiologists were doing for Ebola. But all these predictions were wrong. All the models did not fit with the real situation. And why was that? Well, it is, well, as the image shows, because people responded. And people were often responding with very little means, so the healthcare situation in countries like Sierra Leone is not very good. But nevertheless, of course, there were people with training, there were people with some health education, there were village chiefs who sort of realized we need to protect our people, so we need to do something. Of course, they had some experience with other kind of infectious diseases. So a lot of the let's say the spreading was sort of stopped depending on how effective these local teams, so there were Ebola task forces, locally created health task forces, that often were very effective in stopping the infections by doing simple things like roadblocks that you see here on the picture. So village chiefs who were saying, okay, no one from outside can come into our village unless the person has a certificate that he or she is not infected, yeah, you have to stay out of the village. That is a very simple measure, but very effective in terms of reducing the spread, right? So these kind of basic measures and the organization of them on a very local level created the erratic pattern as we saw on the previous slide. So that has well, as I say, important implications for understanding these kind of diseases, understanding these kind of epidemics, right? You need social scientists. You need people who can, well, investigate and map, okay, what is the local capacity? What are people doing? What is the level of knowledge of the community? What is the number of specialists and trained nurses that you have in a particular area? And what do they do? How do they communicate? All these are social science questions that are very important to, well, do two things: understand these kind of disease patterns, but also then, of course, come up with solutions. Example 2, a bit closer. It's a study I was involved in, indirectly from colleagues. It was involving people in Cambodia doing a study on pig diseases. Again, pigs are animals that are associated with quite a number of different diseases, zoonotic diseases. African swine fever is the most prominent one, but also coronaviruses and influenza viruses. All these things, all these microbes and pathogens, they move easily between pigs and humans and other animals, wild animals. So pigs are one of the species that there's quite a bit of interest in. So what they did, these are images of how pigs are held. You can easily see how directly these animals are interacting with both human beings and other kind of animals. So poultry again is another way in which these pigs are interacting with other livestock. And what this slide shows is that Cambodia is a very rapidly developing economy. So again, the economy is really crucial to understand these disease patterns. So within, well, 1 or 2 decades, the economic growth in Cambodia was such that the pig industry changed from relatively small, in terms of many farmers, almost every farm had 1 or 2 pigs, into a much more intensified pig industry or pig production. So within a few years, Cambodia changed from a net importer of pigs, of pig meat or pork, to an exporter, right? And that means that the number of pigs on a farm increases. But it also means that the kind of breed of pigs changes, right? If you are specializing in pig production, you want particular well-producing pigs, and of course, pig breeders have made these kind of breeds of the animal that allow higher production, right? But it also means often that the disease resistance of these animals is reduced. Many of the pigs that are used by smallholder farmers are, well, local breeds that may not be so high productive in meat, but they are often very resistant to a number of diseases. So they can survive in the sort of semi-wild environment they're in. So what my colleagues were doing, they were taking samples and did PCR tests. It's probably all familiar to you. And yeah, their findings were saying exactly what I already indicated, that there's a significant difference between pigs from commercial and smallholder farms. So in the commercial farms that are rapidly emerging in Cambodia, the number of viruses and the number of potential pathogens was much higher than in the smallholder farms, right? So again, you see 2 things: how the kind of agriculture you promote as a government, or the kind of measures you take to produce these animals, have a direct effect on health risks. And secondly, the economic activity of humans. So not just in terms of making money, but also how do you do it? What is your method of production? How do you make sure that you, create enough hygiene in your pig pens? And how do you avoid the transmissions of pathogens, etc.? So all these things are really crucial. And early detection, so this is an example, it's a case study of disease surveillance in pigs, can help to understand these patterns, but you need to integrate them with these kind of social, economic information. So moving from identification of the problem, so I hopefully now made clear that for a wide variety of diseases, I've given 2 examples. This integrated perspective of One Health is really crucial, it's really important. So what can we do about it? Well, first of all, we need to understand these infectious diseases as an integrated thing, and social science can help to explain the unpredictability. That's some of the things that I presented from the 2 examples. Unpredictability in terms of disease spread. Epidemiology requires social analysis to understand why in certain areas it does and in other areas it doesn't spread so quick. It also needs understanding of the changes in the development of your economy, of your society in general. And of course, existing knowledge and technologies are often not adequate enough, right? So what kind of innovation do you want to stimulate? And these are policy questions. In terms of research, One Health, as also this image shows, is not new. I mean, I didn't invent it, and WHO didn't invent it, but it was sort of emerging awareness among researchers, among governments everywhere, to integrate these kind of things. And there's a lot going on in terms of initiatives to cooperate and to collaborate. And this is just an image of all the important elements that are there. However, most attention is for bioscience and public health. And of course that's obvious, right? Because these are health challenges, these are disease risks that we're dealing with, so we need our virologists, we need our epidemiologists, we need our, well, medical people to deal with that. However, as I hope to have explained and clarified to you, we also need the social scientists, the economists, the anthropologists, and people from innovation studies, or science and technology studies, and maybe even history, right? Long-term disease patterns are really interesting to study. And also study historical cases. I already mentioned the Spanish flu of the 1910s. And indeed, once the COVID outbreak was there, you saw an increasing number of books about previous outbreaks, about the influenza, Spanish flu in the 1910s, or even the plague in the Middle Ages, etc. These got renewed attention of what can we learn from how people responded to these health crises in the past. So this is, my speech is also a bit of a promotion talk for the social science. Just to give you an impression of what we're doing in Wageningen University, we have a One Health initiative. It's called ERASE, which is a sort of global abbreviation for the emergency response. But we probably will continue as a One Health program or a global health program. And this is an interesting figure because it shows, it basically is a cycle, right? So there's elements of response in the top right, there's elements of recovery and learning, there's elements of prevention, and then there's elements of preparation, right? So of course, what you want to establish is that your gap here between preparedness and response is as effective as possible, right? So you don't want to have a huge disaster here so that you have to do a lot of mopping up in the response. No, you want to be as prepared as possible so that if there is an outbreak, you can respond quickly and effectively, right? So that we don't have another worldwide pandemic. And of course, these elements, recovery and learning, are really important. This is what, let's say, what we're now in terms of COVID-19. COVID-19 is not fully away. There's also in Europe, and I also hear from Indonesia and other places, there's now again an increase in cases. So the virus is still developing and doing its work, but luckily the effects are not as devastating anymore. But still we are learning. Even the Ebola cases, it's a long time ago, almost 10 years now, the big outbreak in West Africa, but there's still studies going on that do this kind of recovery and learning research. And then indeed, prevention and preparedness, which is the sort of solutions side, right? What can we do to be better prepared? Well, there's a number of things mentioned here, and if you want to know what these are, a number of, example studies. As I said, the ERASE is probably where you can find it. You Google it. But we don't want to know more again about wild animals. That's because we are an agricultural university, but these are all about zoonotic diseases and AMR, antimicrobial resistance. It's also part of it. Again, focusing on the social science part, what can social scientists contribute? Well, two things I listed here. One is about governance. So a lot of measures require legislation, but they also require that there are investments in the capacity of government institutes, the capacity of local government. The governments need to communicate and organize themselves. So all these things are really crucial. Regulation and regulatory responsibilities are very important, but typically governments everywhere in the world, they also want to reduce their expenditure. So, and there's a lot of pressure from international agencies like the World Bank. Oh, don't make your government too big, right? So these are the sort of national and international social science issues and policy issues that are really important. On a more small scale, local level perhaps, it's about how to connect general knowledge, the kind of knowledge that we produce in universities of medical support, etc. How do we connect it to local knowledge? right? Again, at community level, there are often specialists, there are nurses, but are they trained in the right kind of profession, or are they trained in the right kind of solutions? Do we need to make new training programs? Do they have enough equipment? Do they have access to the internet, etc., etc.? These are all questions that are very important to make sure that the general knowledge that we produce in universities and research institutes, and that governments say we need to spread them across the country, indeed reach the local level, reach the different communities, right? And that involves what I term transdisciplinary science. So interdisciplinary science is connecting different disciplines, and transdisciplinary science is also connecting local stakeholders, so health workers, community members, etc., government agencies. And they have to become the problem owners. So only if you work together, if you collaborate, then you can make effective teams for prevention and treatment. So again, if we talk about solutions, like in research, also in technology development, there is a lot of emphasis for what I term high-tech solutions, right? I've seen it here in Indonesia. There are many apps, many applications that you can use for telemedicine, right? Halodoc is the most used one, I think, but there are many variations of it. And that's because all these small companies, or even bigger companies, you think, hey, we can make some money if we develop an app like this. We can, we have this technology, we can use it, etc. And it's considered to be interesting because it's high tech. It can be used on your smartphone, right? It has this great attraction to people. And of course, it can be useful. There's increasing studies now on how useful it really is, and some say it is very useful, others say, well, it's only useful for some and not for others. But these are exactly the kind of research questions that we need to ask, right? How effective are these technologies? How effective are these tools? Who uses them and who does not use them, right? And what are the effects of this difference of use and non-use? Because it can be increase the gap between, well, the people who already have access and the people who have not or not enough access to the health system, right? So again, we need more emphasis for the social innovations, but also readily available solutions. I've given the example from the Ebola case. You can stop infections with very simple measures. You don't need a smartphone to make a roadblock, right? So that is a very simple example, but often there are very simple examples. One of the first things that we were looking for in the COVID-19 crisis was not smartphones, it was masks, and we still use them, right? There was a huge shortage of masks, and no one predicted that. Because mask is a very simple technology, it's just a piece of cloth. Well, it's a bit more than that, but with two elastic strings, right? We don't consider that high tech. But still, it's a crucial solution in order to prevent transmission. So there's a tendency to overlook these kind of simple tools or simple measures and have a lot of focus on the high tech, on the big machines, on the ICT, etc. Again, we need those high tech, yes, but we need to use it smartly. We need to use it in combination without overlooking the small technologies, our mouthwash, etc. So we need integrated social and technical solutions. The risk of focusing too much on the high tech is what is in sociology is called techno fixes, right? So, and it suggests that these kind of complex issues that we're dealing with and that One Health approach is trying to address are narrowed down to one simple technical thing. Okay, if only we have this equipment, if only we have internet everywhere, then we will have the solution. If only we have these machines in all places, we will be able to prevent the next epidemic. Very unlikely. There's never, for complex problems, there's never a simple solution. You always need to integrate it with a lot of other things. But of course, and this is something of the risks that I want to highlight here, there are people who can benefit from this, what I call techno-fix approach, right? It's often the big companies and also national governments, they like that, because then they can say to their constituency, to their voters, look, we have this machine, don't worry, tomorrow everything will be better, right? And that is a pattern that you see happening a lot, and that's the kind of pattern that I study in my field. These techno-fixes also ask for a specific kind of social science. And that's also what you see happening a lot. And it's kind of social science, I call it, after the design and product is finished. In the environmental sciences, they call it end-of-pipe solutions. Right? So you have a very polluting industry, and you put at the end of the pipe where the wastewater hits the river or something, or where it comes out there, you put a filter. That's typically end-of-pipe solutions. And that's very common in all sorts of technological applications. Okay, you don't do anything about the design, but you just put something in the end to avoid the worst effects, right? And that is often also on a bigger scale what a lot of these social sciences are doing. A lot of the, what is called science communication is not questioning whether we're doing the science right, it's questioning whether the science is rightly used by the people, right? Again, it's a difference there between questioning what do we need, while then questioning how do we apply it. Right? And again, I'm not saying that these are not relevant disciplines. We need to have them, yes, but we not only need to have them because we basically have to understand the entire route from before, during, and after the design and product development. And I've given here an example from AI applications. AI are controversial. I mean, there's a lot of debate in social media and international media about AI, does it replace human cognition, etc., etc. But the real important questions are much less prominent, which is what does it mean to produce AI? It takes a lot of energy, so to make all these computer and servers run, you need to have a huge amount of energy. But it also requires a lot of labor. Typically we think, okay, computers do the work for us. No, to make that run, you need, in fact, a lot of new labor. This is an example, it was in the news that a lot of the AI technology companies, they pay low wages in low-wage countries to train the computer. For AI, you need what they call machine learning. You need to train your computer to recognize whatever you want the computer to recognize. And this is done manually by people who are in, well, remote places. And this is about the production of these kind of technologies. Right? So we need to understand them too, to basically ask the fundamental question, do we want it like this, or do we want other kind of solutions, or do we need to mitigate or redesign our solutions? The example I have is from agriculture. This is one of the effects in the United States. There's only basically 2 or 3 companies who own all the data about American agriculture. That is a scenario that is increasingly worrying, people, but also in research and in science, but also people in governments. Okay, who owns these data? Well, apparently only a few companies have all the data about agriculture, and they sell it back to the farmers. But a lot of this data is in fact coming from the farms itself. So the farmers are increasingly saying, hey, wait a minute, you first come with your drones and your monitors, etc., and take data from our fields, now you try to sell it back to us. It wasn't this data from us in the first place. So all these kind of intellectual property or property questions increasingly pop up, and you also see this happening a lot in the medical field, of course, with the increasing digitalization. These kind of questions, who owns the data, who can have access to the data, are very crucial and very important. And indeed, that is what also the Indonesian government realizes. This is taken from a report, it's not very clear, but this report is freely downloadable in the internet. It's about digital transformation in health in Indonesia. And this is one of the pages of the report which highlights basically the main issues in primary and secondary care about data use, who owns the data, who can have it, and who can have access, and how is it best used, etc. These are very good questions in this report. These are the kind of social science questions that I addressed as well. So it's very good to see that, here these kind of issues are also taken up. And we need, again, this kind of integrated One Health approach to deal with these kind of challenges. Right? I'm almost done. Again, this is basically what I was already saying. So we need these kind of integrated approaches and transdisciplinary research. We need to include local level. This is familiar to you. Local level stakeholders, not just the health professionals, but I noticed that there's often also volunteers working with the Puskesmas to visit families and to distribute information to families. There's often school teachers who are involved, who help in the distribution of knowledge. But there's also very simple things like, okay, is there enough internet coverage in this area? What can we do about it? So all these things require involvement of a wide variety of stakeholders in what is known as transdisciplinary research. And yeah, again, repeating what I have already said, there are different ways to do that. Citizen science, living labs, participatory epidemiology, these are all methods that you can employ where you use a combination of medical research and expertise and social science expertise. So again, there's many good examples. You can find it in the literature, you can find it on internet and reports that this kind of approach to One Health yeah, can benefit and can deliver good research and new interesting pathways for solutions. This is an example of last week. There was a conference in Europe, European Agency for Emergency Response and Economic Preparedness. And one of the things that I saw back in the tweet, this is a tweet from last week, is that they say collaborative surveillance. And that is exactly the same word or different word for the same thing that I was just promoting. You need collaboration, right? You don't need to rely on one solution or one type of research, but you need to collaborate in order to yeah, be prepared for the next disease outbreak. And again, transdisciplinary research is really crucial, so collaboration between different disciplines and making these studies integrated and connected. That's it. Thank you very much.
Thank you, Professor Harumat, for wonderful lecture. Now the time for Q&A sessions. I would like to invite you to ask questions to Professor Mat. Ada yang mau bertanya kepada Profesor Mat?
Good morning. Perkenalkan, let me introduce myself. I'm Anggi from Magister Biomedic Universitas Sumatera Utara. It is so interesting. We talk about One Health. One Health is expected to be a solution, especially for zoonotic disease. In Indonesia, Sumatera Utara, the big problem of One Health is rabies. So, for your information, we have 9,000 cases of bite from dog, especially dog. The dog that people is from stray dog without vaccination status. This is not the only one matter, but our big matter is the dog owner is rejected for his pet to be vaccinated because the dog will be eaten. Okay, may you give apa ya? Some advice for our me as a government and mahasiswa in USU here to make our One Health implementation to rabies zoonotic. Thank you.
Thank you very much. That's a very interesting example case. Rabies indeed is it's a zoonotic disease that's all across the world. And it's also a very good example because it exactly is a disease where this combination of high-tech solutions and low-tech solutions can really work well. So I've seen various studies on trying to find out, okay, what is exactly the pattern of the disease and the disease spreading. And as you rightly say, stray dogs is one element, but you need to be precise about exactly what kind of stray dogs are we talking about. Many dog owners leave their dogs open and stray on the streets, but many dog owners, or most of those dog owners, have these dogs at home or on the compound in the night. So what exactly is a stray dog needs further research. So I've seen some studies using collars for the dog with GPS tracking, and they found that what is supposed to be stray dogs is only a small percentage of dogs without owners who not just stray on the streets, but they also make much wider distances. So dogs with owners move on the streets, but with short timefall. And this has two implications, of course. One is that if you target your solutions to the stray dogs without owners, and you can find out with this GPS tracking which dogs they are, then you can be very effective in your vaccination or in your whatever measures you do to avoid these dogs to roam around. So then you cut the rabies transmission much more effectively. And secondly, by finding out that most of the stray dogs, I've seen two studies who come with the same conclusion in Africa and in Asia. If you can then track the owners, you can say, okay, you need to vaccinate your dog, of course, but you also need to make sure that your dog is indeed at home and can't roam around, that it doesn't become a loose stray dog in the night. Right? So again, vaccination, but also knowing what kind of dogs you're dealing with and how they move around and who are the owners is very important information to make effective campaigns, using combined use of high-tech, vaccination, and low-tech, better dog management. Right? So I fully agree, it's a very nice example, and we don't need just virology research or epidemiology research, we also need to have social science research to understand dog owners and how these dogs move. We need people who know how to do this GPS kind of thing. A lot of wildlife research is about tracking movements of animals. We need to include them also in the studies to deal with diseases like rabies. So thank you very much for giving that example.
Thank you. So Professor Marbila. So from Professor Mahat, we can understand that in One Health approach we should collaborate from interdisciplinary to solve any health issues, including the one that asked by our audience here. And we also need to emphasize that the contribution from social scientists, then that's why we need social scientists, because we need someone who invests this ID for dogs, then we can know the status of the dogs. Is there any questions from the audience?
Thank you. My name is Dr. Betty from microbiology. I would like to ask about the One Health problems. Do we have already have the
such a blueprint or template. What are we going to do if there is an infection between a human with animals and then environment? Such as maybe I can give the example like last time we have avian influenza. We already knew that it's from chicken to humans and then so and so. But then what we already do about it, I mean, we have a blueprint or something that this one it cannot be transmitted or this one should be prevented or something like that, so that we can use it for another terms of infection, zoonosis infection. Is it possible like that? That's my question. And then another thing, if we are talking about antimicrobial resistance, if we are talking in the humans, maybe it is like there is genetic influence because the bacteria, it also has already the genetic for resistant antimicrobial. Is that possible in animals too? They have flora normal in animals that change to antimicrobial genetic too. Is there any such a thing of that?
Thank you very much.
Okay, thank you.
That's a very nice question as well. And I think, if I understand the question correctly, yes, there are examples of how to deal with it. There's two things I pick up from your question, whether there is genetic effects in the animals, and I'm not a specialist, but I think yes, so they have the same kind of interaction between resistant genes and the genetic composition of the animals, so that I think is indeed, but you can easily look that up if you if you do some literature search, I think. The other part of the question I take out, what can we do, right? And that I think is really interesting, and honestly I don't have a straightforward answer, but I can give you some examples of experimentation where the use of antibiotics is drastically reduced. And one example is not from chicken or pigs, but it's from cows. So the Netherlands is known for its dairy production, so we have a lot of cow dairy farms in the Netherlands. And increasingly farmers are experimenting with other ways of doing agriculture. Sometimes they call it organic agriculture, sometimes they call it regenerative agriculture. But what they try to do is try to reduce the use of chemicals, including antibiotics. And one interesting example of a farm that uses no antibiotics anymore for at least 10 years is they do two things. So if you go to the Dutch countryside and see a cow, you don't see any horns on the head. He kept cow breeds with the horns on it. He didn't take the horns away. And it's not yet confirmed by research, but there is a suggestion that the horns are not just for protection of the animal, but they also have an effect on the entire health of the animals. So, in short, animals with horns are often healthier than if you take the horns off. The second thing he experimented with is the kind of grass that is fed to the animal. So he experimented with mixtures of grass that include some herbs that they simply grow in the pastures by seeding it, right? So that the animal doesn't eat just one type of grass, but eats mixtures of grasses and herbs together. And that also increased a lot of the resistance of the animal, right? So by changing the diet and changing the way the animal was kept, they could basically bring down the use of antibiotics to zero. And that is, of course, a small example, a small experiment. And increasingly researchers in my university, but all over the world, try to find out, okay, what is exactly this kind of balance? It's the same kind of balance of the opening picture of my presentation, right? So if you create diversity in your system, it can be very effective to reduce transmission or even outbreaks or things like resistant genes to emerge. Right? How exactly that works, it's very complicated, and the research of that is basically yeah, in its infancy stage. But I think that is the future. So both, let's say, agriculture faculties, but also medical faculties will, I think, move into a direction where the prevention issue is more and more looked at from, okay, how can we change our lifestyles? How can we change our nutrition and diets in order that we become less dependent on, indeed, these kind of single breed, big intensive livestock farms, and create a more diverse system. It's very complicated, very long-term perspective, but Wageningen University, for example, it was often known as the university that invented this intensive livestock systems. And now it's even some of the older professors who were part of that, they were intensifying to say, well, we made the wrong decision there in the 1950s and 1960s. We now see that this intensification has all sorts of effects on AMR, on all sorts of other infectious diseases that we didn't anticipate. We didn't realize that at the time when we were promoting this intensification. But now we know we need to change it. We need to change our way of dealing with our animals and therewith with our human health as well. Thank you.
Thank you very much, Prof. Maybe I will ask the first question again. Is there any what we should do to prevent like the avian influenza lifetime cases between human and animals? Is there any One Health proposition or already made standard procedure or something like that?
Yes, thank you. Yeah, sorry, I use the example of dairy farms of cows, but the same principle applies for avian influenza too. Yeah, I mean, I think we still don't know enough about the influenza virus, exactly how it develops. There's increasingly alarming signals that it transmits not just between birds but also other sort of mammals, basically other animals. So that's something we need to know. But again, what you see happening as soon as avian influenza hits an intensive livestock farm, a poultry farm, all the animals get sick, right? Because they are all the same breed. They are all the same. They have all the same genetic basis, so to say, and the same low resistance against the influenza. However, not every animal dies. So again, you see, even within a seemingly genetic homogeneous livestock, you still see individuals who survive. And that is exactly where breeders are attentive to, because those are probably the animals that have resistant genes, right, that deal better with the, and then you need to find out, okay, what are these genes and what can we do with them to increase the livestock that we have with that kind of resistance. Again, it's a long-term solution, but as with the example of the cows, if you increase the resistance in different ways of these animals, of poultry, then you probably can reduce the effects of the influenza, but also the spreading and the development of the influenza virus. In the end, you need to find a balance. I think there's no disease that you can fully eradicate. I mean, the most prominent example is what's the polio. We thought that we had fought polio. There was even a formal declaration that polio was eradicated from the world, but we still see it re-emerging in small places. So, I mean, Mr. Pasteur was right in the sense that we have to deal with the microbes and the microbes.
Is there any question? Ada yang mau nanya lagi? Pakai bahasa Indonesia juga boleh? Ada? Okay, maybe last question from me. I have one last question, because you raised issue about high tech. And you also raised a concern regarding machine learning, AI, and so on to such kind of innovation and solution for future. How can we solve the environmentalists? As we know that the development of AI, large language model, also produce carbon emissions, which is against also and harmful for the environment. Because we said we want to implement this approach for the future, and since now we already know that there is a threat of the weakness of this technology, because it's also act a role as a carbon emitter, which is harmful to the environment. What do you think about this? Because we are talking about balance between pure science and social science. What do you think? Thank you.
Well, yeah, that's a very good question, and then also a big challenge. I think there are two answers to that. Of course, one of the things that is increasingly already going on is the governance of AI or high tech, right? So I gave the example of agriculture, where a lot of the data is being owned or being collected by very few big companies, and that did ring some alarm bells in the governments, also in the United States. So there is a big debate about who owns this data and what kind of privacy and property regulations do we need to have around these kind of issues. Then, of course, if you talk about medical applications, you also have to deal with privacy issues, right? One of the things that's one of the elements that it's most European countries, but also in the Netherlands, we have a very technically sophisticated medical digital system, but in the connection often is not made due to privacy issues, right? So you need to find a balance between how do we prevent that everyone can just snip into your medical files. We don't want that, but neither do we want such strict protection that when there is a medical emergency, the doctors can't access your data because it's restricted use, right? So you need to strike a balance on the governance. So you need to have smart and good governance systems to regulate those kind of things. And the other element that I want to throw in is the kind of social science research question, or the innovation research questions. What kind of innovation do we really need? Again, there's a term, what we call responsible innovation, or responsible research and innovation. That is a way to ask these kind of fundamental questions. Do we really need these kind of technologies? And if we need them, if we think we need them, how do we want them to develop, right? And often tech companies have a completely different understanding of what the people want, or the concerns of the people, than what the people really express. One of the examples I often use in my teaching is self-driving cars. This is Elon Musk. He has this big image, and he was already predicting 10 years ago, in 5 years' time, we will have a self-driving car that transports you. His image is that people want to move fast and that they want to move cheap. Yes, that's correctly. But if you ask the people, and many social scientists, many of my colleagues have done that, they also say, yeah, but we're also worried about who is responsible if the car hits a pedestrian, or whether I get hit by one of these cars. There's no driver, so who's responsible for this? Who takes the cost of my medical recovery if my leg is broken due to a self-driving car? So, and these concerns are often not addressed by Elon Musk. You never hear him talking about these things, right? And that is exactly the kind of things that we need to do. We need to increase the sort of, make sure that tech companies not define the problem for us, but that they really are opening up and being enforced by rules and regulations to listen well to the needs, but also to address them in a serious way. And that's, I mean, again, like with government change, it's a long process, but yeah, it's unavoidable, I think.
All right, thank you. Is there anything else? Anything else? Oh, maybe one more question.
Terima kasih moderator, boleh pakai bahasa Indonesia. Nah, ini dari tadi ceritanya kan One Health untuk kayaknya untuk penyakit menular. Kalau untuk penyakit yang tidak menular, apakah
like snake bite, not NCD such as diabetic or other degenerative disease, but like snake bite or birth infection and so on. How can we handle this using One Health approach? And is there any technology to use to solve these issues? Thank you.
Yeah, arguably that's also one health issue because it covers animal and human health. I must admit I'm not a specialist in this area of snake bites and other animal bites. There is some research also from social science side on what they call bushmeat trade. Bushmeat is basically wild animals that are hunted and trapped and sold. And typically what you see, or what the research shows, is that hunters often they are very aware of the risks of being connected with the god, and they also wash their knives and their weapons, etc., in a very effective way. The real disease risks are emerging when the meat is transported, and when the meat is stored, and when the meat is stored for too long. That's when you get the highest disease risks. So the direct interaction with wild animals, yes, snake bites is another example, but snake bites really are most dangerous for the venom, not for infectious diseases. But so that is a relatively small risk. Of course, we need to address those things. But if I can take your question a bit broader, I think there are more One Health issues, also nutrition issues. It's not what they call non-communicable diseases. Is a One Health issue because obesity, but also stunting, which is a big issue here, as I understand, they relate to how we deal with the environment. If we have a healthy environment, and if our farms and the kind of crops we grow, and the access we have to vegetables and other food ingredients of our diet, if that increases and becomes more diverse, our diet also changes, right? So there has been studies on long-term patterns between the reduction of crops. There was a study from India. So small farms typically were growing lots of different grains like millet and rice, but also wheat and etc. Different types of these grains, but also vegetables. And over 4 or 5 decades, the amount of crops grown on a farm has reduced. So typically a farm now grows either sugarcane or wheat or rice. So, and with the reduction of diversity of crops, you see a similar increase of non-communicable diseases like diabetes and stunting and other kind of what they call deficiency diseases. So again, this affects health issues, yes, but it also affects what kind of agriculture do we have and what kind of agriculture do we need, right? So there again, I mean, these are complex issues, but the way we interact as human beings with our natural environment is we need to ask many more fundamental questions about how we do that. The way we do it now is to basically everyone wants to live in the cities and we want to stay away as much as we can from farming or whatever, but maybe we need to change that.
Oke, jadi Prof. Maat bilang mungkin untuk kasus-kasus injuri seperti gigi dan ular dan lain-lain itu memang resikonya sangat kecil untuk bisa diselesaikan dengan masalah penerapan pendekatan One Health. Tapi Prof. Maat bilang bahwa One Health itu bisa ditarik lebih luas lagi ke penyakit-penyakit non-infeksius. Dia memberi contoh, salah satunya adalah masalah-masalah gizi. Jadi masalah gizi bisa terjadi oleh karena adanya intervensi ataupun masalah pada lingkungan. Misalnya apakah bencana alam dan lain-lain bisa mempengaruhi diversity atau keberagaman dari crops kita, tumbuh-tumbuhan kita. Misalnya bencana alam jadinya gagal panen, masyarakat kurang produksi dan lain-lain sehingga gizinya berkurang. Bencana alam juga atau masalah lingkungan lainnya juga, banjir dan semacamnya juga dapat menghambat akses masyarakat ke layanan kesehatan yang juga dapat mempengaruhi status kesehatannya. Dia jadi sulit untuk kontrol gula darahnya, kontrol hipertensinya dan lain-lain. Makanya dengan pendekatan One Health ini luas bisa dipakai walaupun awalnya cuma fokus ke masalah penyakit-penyakit infeksius, zoonotik dan lain-lain, tapi pendekatan yang sama, dengan pendekatan yang sama kita bisa menerapkannya untuk berbagai macam masalah, baik penyakit infeksius maupun penyakit non-infeksius. Kira-kira demikian. Okay, due to our limited time, I think that's all for today's session. Please once again give big applause to Professor Harumaat. Before we end up the session today, we would like to invite Professor Maat and Dr. Iwan, Dr. Suna to come in front to have the photo session together and giving the souvenir ulos provider. Now we would like to invite all the guests that attend today, Dr. Suna, Dr. Ayu, Dr. Dina, and Laila to come in front, Dr. Teddy, and Dr. Evita, please come in front to have a photo session together. Ya, jadi kepada para undangan diharapkan untuk maju ke depan untuk berfoto sesi.
Once again, 1, 2, say cheese!
Dengan berakhirnya acara sesi foto bersama, maka berakhir pula ini. Terima kasih pada para tamu undangan yang telah berhadir dan juga para pembicara dan para dokter sekalian. Semoga ada manfaatnya. Sampai ketemu lagi di event berikutnya. Assalamualaikum warahmatullahi wabarakatuh.
Penelitian yang HSPB